smells like
Okay, first let's start with calculators. Pick out your calculator, please. On the top row, there is a button that says mode. Press that mode button.
Whoa.
And there's a whole bunch of information in there, but there's two things that you need. The second or third line down, it says float, and then a bunch of numbers following that. Make sure that float is highlighted. And then below that, it says
Radian.
Radian or degree. Yours should be in degree. If it's not, highlight it.
How?
And hit enter.
Oh, highlighted. Wait, is it highlighted?
Now here's the tricky thing about this. If your calculator is in radians mode, you will still get answers. You will not get an error message. You'll get answers, but they'll be wrong. Okay. So here's a fun trick you can play on your neighbor. Right before the quiz, the next quiz that we take, when they get up to blow their nose or something, just reach over and put their calculator in the wrong mode. That's hysterical. Yeah, because then they get all the answers wrong. Yeah, don't do that. Your calculator should be in degrees, and there's no reason for you to change it out of degrees for this class. When you progress through math and sciences, you will change it. For instance, my calculus kids, their calculators are always in radians because we operate in that different mode. Okay, but yours should stay in degrees. All right, good to go? And we'll check that later to make sure everybody's ready to rock and roll. What I'd like you to do is talk with your group for about 2 minutes. And the question is, how would you measure the height of the flagpoles out in front? I need 2 solid/realistic strategies. Climbing the flagpole is not a realistic strategy. No one's going to allow you to climb that flagpole without getting tased.
Do it Captain America.
You buy a
and let it fall down.
Oh right, the Captain America where
The
you.
top to get the flag, you just hold the pin and let it fall.
How about we just
Do a Mulan.
really long
Do a
measuring stick?
Mulan where you put the medals around the pole and then you climb it down.
Here,
Are you taking a string and you put it in the top and then you let it fall down and you take the string?
If you know the length of the flag,
a long
then
measuring
you
stick.
can just like
It's like
it's like the like the whatever it's called, like the rope that you pull to let the flag up and down. Take that off and measure that.
Okay, so far we have the
It's
Captain
longer
America.
than the thing because it
It's
wraps
actually
up
shorter.
around the and then divide it by 2 and add it.
So far we have a pole Captain America.
So far, I need to make a note. I found Dude, I have schizophrenia.
Actually does.
Do you even know?
I wrote trigonometry.
Even know what schizophrenia is?
I've heard of it, but hey, it's a math class, right? So how can you act? Well, I guess you can you could take the midpoint and then do the thing.
Trigonometry.
I don't know what I'm saying.
So, to measure.
Just like cut the bottom off and let it fall down and then just like
Right. That's yeah.
But then there was
That's
still
Captain America.
some, some metal in the ground.
wouldn't we like scaffolding like all of them already about how long the flag is?
All right, ideas. Lily. Just measure the shadow, and the shadow would be the same height as the flagpole.
Shadows get distorted.
Okay. Still, question or answer? Were you raising your hand? Oh, sorry. What do you got, Ted?
Tape measure.
Oh.
That's it. And you would do the pole. You would measure.
How are you gonna get to the top? You're gonna fly up there?
Who said that?
Who said what?
How are you going to get to the top of the flagpole?
Oh, I said that.
It's a little bigger than 25 feet.
Cherry picker. Okay. So nobody would care if you just backed the character off and in front of the school.
If you just like spin things.
Actually, if you see Rogers before,
my God.
And yeah,
Okay,
the-
okay.
Jump on a grenade.
Oh, I want to do that. Dude, I want to do that.
Okay. Eddie,
We said pull a Captain America.
I'm sorry, what?
Pull a Captain America. Let the flagpole fall down completely,
And then you can measure
and
it.
then you measure it sideways.
That's a little reason.
Oh, I thought you said rise it up and then do that.
Yeah, we don't have a name for it though.
Again, you missed
Captain
the
America.
realistic part of that.
Captain America did it. That's realistic.
Right, and that's fiction.
If
That's
we did
real,
it
dude. That's a different universe. It's part of the multiverse.
at nighttime, and no one was there.
Part of the Rudolph game. Your jacket Santa.
It's not a horrible idea.
What was that?
It's got to be on some paperwork somewhere, right? Somebody paid for that flagpole to be
I'm the
installed.
wizard from
What do you got?
Clans.
Fireball.
But we have like the
But you're going to tell us anyway.
yeah, we have the measuring app on our phone or like our iPad, and we can just measure.
Oh wait. Or you can like you throw your phone up to the top and see how much the
I've never used it, but
Just like you know,
yeah. Get enough meter sticks to reach the top.
I'm gonna measure like a straw.
That's more realistic than
2,320.
Okay, so let's suppose you work
It's the
on
most like the second week of school.
just,
How'd you change your background?
you're just going to go up right now. Just hold it right on.
So did I.
Okay, so at some point, hopefully before the weather turns brutally cold, we're going to go outside and figure out a
What I
way
got?
to measure those flagpoles, which probably won't involve root striking them out of the ground.
No, you can take the screws out like he did.
What if you all just get on it?
One of the techniques we're going to use is some. Good question.
I was gonna say a solution for the flagpole.
Go ahead.
You could use the flag to measure the pole, or just like measure how tall the flag is and like, fill it in.
Be more specific. I think I know what you're talking about, but I don't want to assume anything.
Yeah, like, matching like the poles, this giant like space, and then you place like the flags there, how many flags you put in height of the pole.
Okay. Allie, another idea?
No, I have a question.
Certainly.
You mean like the pole itself? Or like, do you include the circle part?
Yeah, you-
too?
We want to include the circle on top. Yeah. Beautiful. Okay, so proceeding with trigonometry, which is what we're going to study today, which is a technique for doing these kinds of things, we have to come up with a way for labeling a triangle. Now, not every triangle is going to be labeled ABC. It could be XYZ, it could be DOG, it could be CAT, whatever it is. But we have 3 vertices, you're used to this. However, what we're going to start doing now is instead of using capital, or not instead of, but on top of using capital letters for the vertices, we're also going to name the sides in correspondence with the angles. Okay, so notice in this picture, angle C is the right angle. Therefore, lowercase c is the side opposite the right angle, also known as hypotenuse. Okay. Angle B is one of the acute angles, and side B is across from angle B. And last but not least, angle A with lowercase a being across from angle A. So now there's a big difference between capital A and lowercase a because they denote 2 different things. Uppercase A denotes an angle measure or a vertex. Lowercase a denotes a side length. If you change the vertices, that's fine. You just have to make sure that you change your corresponding sides. Also, the biggest problem that people run into here is mislabeling the triangle. So you've got to be sure that each of your letters are opposite each other. So if that vertex is angle P, if the right angle, for instance, is angle P, then lowercase p would be the hypotenuse.
When C is the right triangle.
Are we good with that concept?
Yeah.
Because what's going to happen is you're going to be given information about a triangle without a picture, and you're going to have to draw a picture and label your sides and angles correctly in order to solve these problems. So this is going to build on the 30, 60, 90 and the 45, 45, 90 triangle. So you'll recall that we did that because that gave us two special right triangles where you were only given one side length and allowed us to solve for the others. If we have two side lengths, then we could just use Pythagorean theorem all day long, no problem. But now all of a sudden we've got situations where we only know one side length. Trigonometry allows us to do the same thing, but doesn't restrict us to just 30, 60, 90, and 45, 45, 90 triangles. So we can look at triangles with any angle measure as long as it's a right triangle. Okay? So we've got three trig functions we're going to focus on. There are 6, but we're only going to do 3. Okay. Sine, cosine, and tangent. They're abbreviated SIN, COS, and TAN. Please don't call them sin, cos, and tan. It's just bad. Okay. So go back to your calculators. On your calculators, you should see 3 buttons labeled sine, cosine, and tangent. Good? Yeah, found them? Okay, good. So we're going to use those in a little bit. Now, these are functions. And by functions, it means it takes a number, it does something to it, and it spits out another number. It's like squaring. You take 2, you square it, you get another number 4. You take 3, you square it, you get another number 9. The same thing is true with trigonometry. Now, how it does that is not really what we're going to talk about. We're going to consider this like some magic function. It just does some amazing things. We'll learn later exactly where these numbers come from. And back in the old days, we didn't have calculators. And so we used to use something called trig tables. And many of you didn't notice or haven't noticed this, but my desktop, aka PASS, has trig tables on them. So you see, where are we? Logarithms, natural functions.
I see it.
Yeah, so you see tangent. There's tangent, there's sine, and there's cosine. So if I wanted to know a function, I'd have to look up a table like this. So that when you were taking in old days, when you were taking a trigonometry test, the reason this was a desktop is because then you could just look at the desktop. But there was also trig tables that you would have to carry around that would tell you what the values are. Fortunately for you guys, you have a calculator.
Oh yeah.
So it makes it a little bit easier. Okay, so how does it work? Well, here's our triangle again, just some generic triangle. And the trig functions initially are defined as ratios, like it says. They're trig ratios. And so if we want to know, for instance, the sine of angle A, and we're going to use A as an example, it's just a ratio. And you can do ratios, right?
Yeah.
Okay, good. So the ratio for sine is the opposite side over the hypotenuse. Okay, so in this particular triangle, it's A over C. Now, A over C is not going to do you any good because if all of a sudden I give you a triangle labeled PIG, you're not going to be able to do that. So what's more important is the opposite over the hypotenuse. Okay, so just to make sure you understand this, suppose I asked you for the sine of angle B. What would the sine of angle B be? Say again? B over C, good. The opposite side from angle B is side B, the hypotenuse is still C. Cosine is adjacent over hypotenuse. Okay, so this one requires a little bit of explanation. If I start with angle, what does adjacent mean, by the way? Next to. So if I start with angle A, there's actually 2 sides next to angle A, B and C. Why did I choose B? Because that's the adjacent leg. The other adjacent side is the hypotenuse. So adjacent over hypotenuse is cosine. And then last is tangent. And tangent is opposite over adjacent. No hypotenuse involved in tangent.
Finally. He's sitting with Jack.
And so when you tell somebody that you're studying trig, they might fire this phrase off. So katoa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent.
That seems like a lot too. That seems like like an acronym. I'm never gonna remember.
Okay.
So kata. Wait. So.
Then don't remember it.
No!
So,
Wait!
No, I erased it.
Can you say it again?
No, you can figure it out. It's right there.
Sokotoa.
so kata. Come on, even I know it.
Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Question.
Are they so dumb? Those are like super stupid.
Angle C.
Excellent. Seabass just asked a very good question. What happens if we do the, which one did you say?
For cosine angle C.
Cosine of angle C. Some weird stuff happens when you start playing with the right angle. Okay, so for instance, if we take the sine of angle C, well, you tell me, what would the sine of angle C be?
Oh wait.
Which is?
That's what I do.
Which is what? On your calculators, hit the sine button, then 90, and hit enter.
Sine. Wait, should I end the parentheses?
No.
1.
1.
I got 30.
So it doesn't matter what shape, or I shouldn't say shape, what size triangle we have or how big the angles are. If you take the sine of angle C, you get 1. Okay, so what about the cosine of angle C, which is the one you asked about, right?
Yeah.
So which one is adjacent? Or neither. I mean, so that creates a confusion. Is it A or B? We know which one the hypotenuse is C. Okay, so take the cosine of 90 degrees.
0.
0. Why is it 0?
0. Because the cosine is the
C over C.
yeah, because it'd be C over C, and that's just
No, sine is C over C.
but they're both C over C.
but-
Oh, dude,
Okay, so there's no logical explanation yet about why the cosine of 90 degrees is 0. Then the last one is the tangent of the right angle. So which one is opposite?
yeah.
C. Which one is adjacent? Same problem. Try taking the tangent of 90 degrees on your calculator. Error.
Wait,
I got
take the
-1
tangent.
point something. Jacqueline.
No
Oh,
way.
Right.
Domain?
Domain.
Oh, because you can't divide by 0. I see.
You're in the wrong mode.
Probably in radian.
Yeah, you're in radian.
You're in radian.
Well, Alex is not Rudolph for him.
So we'll talk later about why we get the sine of 90 degrees is pretty obvious. The cosine and tangent isn't so obvious why we get those weird answers. So we'll talk later when we have a little bit more knowledge of why that works out the way it does. Okay? So, I have a triangle that's labeled differently. I know it's a right triangle for 2 reasons.
Is this for all triangles or just right triangles?
Just right triangle. Okay. I know it's a right triangle for 2 reasons. Number 1, there's a little box down in the corner for E, and 3 squared plus 4 squared is equal to 5 squared. Now, as we get more in depth into this, some of you are going to try to do more work than you need to. Remember, the trig functions are simply ratios. Some value over another value. So for instance, if I'm looking for the sine of angle A, what is the sine of angle A? Haley? No, because that only applies to the ABC triangle we did before. Don't think about A over C. Think of it as opposite, adjacent, and hypotenuse.
Wait, which one are we doing?
Sine of A. No. Evan?
4 over 5.
4 over 5 is correct. Sine is opposite over hypotenuse. The hypotenuse is the 5. The opposite side from angle A is 4. Therefore, the sine of angle A is 4/5. Evan, you want to keep going? What's a cosine of angle A?
It would be 3/5.
Perfect. Cosine is adjacent over hypotenuse. The adjacent side is 3. The hypotenuse is 5. Keep going. Tangent of A?
3/4. No,
Nope.
4/3.
4/3. Very good. Opposite over adjacent. Okay. So let me write those down for those of you that are visual learners. All right, Evan, back to you. What's the sine of P?
3/5.
Good. Cosine of P?
4/5.
Good. And the tangent of P?
3/4.
Notice anything?
I do
Evan?
notice.
The two top numbers just form the next, the tan.
I don't know if I understand what you're saying.
Tangent. The 3 and the 4
Yeah.
are both over 5, and if you take those two, they form the tangent.
Ooh. That's interesting.
Oh wait. Oh dude.
Mathematically speaking, if you take 4/5 and put it over 3/5, that's equal to 4/3. Huh. That's interesting. We don't normally talk about this in here, but one of the things that's true is that the sine over the cosine is equal to the tangent.
So Evan has reminded us in a way.
Yes. The other thing you will notice is that the sine of one angle is the same as the cosine of the other acute angle. The cosine of one angle is the same as the sine of the other angle. And how do the two tangents relate? Not opposites.
Just opposites.
Not opposites. Just flip them, also known as
Flop. Flop.
what? Flipposite. Not a flopposite.
It's no, it's a flop.
It's called a reciprocal.
Guys, come on.
Welcome to Honors Geometry.
We just saw that.
Okay, so this we already talked about. What happens when you try to take the tangent of angle E? We addressed this already, that we don't know which side is the adjacent. We know what the opposite is, because that's the hypotenuse, but we don't know which side is adjacent, and that causes problems. So like I said before, the easiest way to handle that is just avoid it. We will very seldomly, if ever, take the sine of 90, the cosine of 90, or the tangent of 90. We'll talk a little bit more about why that doesn't work in the future.
Well, are we ever gonna have to find it?
Yes, but not until we talk a little bit more about why it does or doesn't work.
Okay, so.
Okay. All right, just to make sure that your calculators are in the right mode, take the cosine of 41 degrees. And you should get 0.7547.
Yeah.
No. Tangent of 74 should be 3.4874, and the sine of 2 degrees is 0.03.
How do you know this? Wait, how do
Pretty
you
much,
know?
if you got one of those values, you should get all of those values.
Oh, but you just fucked me.
Where's the cosine of 41? No, I meant Mr. Reed's wife.
Ellie just asked a good question. If it's in degrees, will it affect anything else on the calculator? The answer is no. It's not sorry.
That's my phone.
Question? Correct. Yeah. When you're dealing with a 30, 60, 90, and a 45, 45, 90 triangle, I'll expect exact answers. But when you start dealing with trig, it's very seldom that you're going to get nice, pretty answers.
Wait, it won't go into a fraction either.
Jack, I was just talking and you shouted wait.
Oh, I'm sorry.
So now I won't wait for you until you learn to behave yourself.
Okay.
Okay, so example 1. Solve for x and y. Now this is going to require some conversation and an example. I'll walk you through this one, then I'll cut you loose on the others. First of all, I am sure that this is a 90-degree angle because there's a little box down in the corner. This only works for right triangles. Now what about non-right triangles? Yeah, that comes later in the week. This is a 90-degree angle. I've also looked and seen that it is not a 30-60-90 nor a 45-45-90 because I've got a 40-degree angle in there. So this allows us to solve for triangles, just about any triangle, given the information that we know. So I'm going to take you through it very simply, and some of you probably don't need this simplistic of an approach, but just to make sure we're all on the same page. Cece, you want to solve for x or y first? There's no wrong answer. You're good. X. Fine. We'll solve for x. Okay. By the way, how big is this angle? 50. Okay, very good. We won't need that, but I'll just throw it in there. I'm going to work with this angle, and I know this piece of information. I'm solving for that piece of information. Okay, so from the 40-degree angle, is the x side the adjacent or the opposite side? Opposite. Is the 3 the hypotenuse or the adjacent? Hypotenuse. So I'm looking for the opposite. I have the hypotenuse. Which function is that? Sine, cosine, or tangent? I didn't hear you.
Can you repeat the question?
Sine. I think it's sine.
I'm looking for the opposite side. I have the hypotenuse.
Sine.
What sine function? So I'm going to set up an equation. Okay, that's the hard part. Solving this should be easy. So again, looking at the piece of information I want to find and what I know allows me to set up this equation. How do I solve that? Multiply both sides by 3. Now, one thing you want to do is notice how I wrote this. I put the 3 in front. And the reason I put the 3 in front is because that will eliminate mistakes happening like taking the sine of 120 degrees. You see how that would happen? It would take the sine of 40 times 3. The calculator would see that as 40 times 3, do 120, and then take the sine. Okay, plug and chug in your calculator. What's 3 times the sine of 40? It's not something I can do in my head. I haven't memorized the trig tables.
Okay.
Say again?
1.928.
1.928.
2, 8, 3. Wait, isn't it 4?
Does that answer make sense? What answer wouldn't make sense?
4.
Why? Perfect. Okay. Now, there are 1, 2, at least 3 ways to find y now. What did you say, Deb?
The Pythagorean theorem.
You could use Pythagorean theorem. Now, the reason I would say Pythagorean theorem is probably not the good way to go is that because that value of 1.928 is an approximate value. Unless you stored that answer, I would stay away from Pythagorean theorem. And because we want to get these as accurate as possible. All right, so method number 1 would be Pythagorean theorem. Method number 2. I'm looking for y. I have the hypotenuse. Y is the adjacent side. Okay. What function is that? Cosine. Set up another equation. Cosine of 40 degrees is equal to y over 3. Solve for y. 3 times the cosine of 40. So therefore y is equal to?
Same as that.
I got this.
2.298.
We're way past that.
Cosine of 40.
What'd you say, Anna? Sorry.
2.298.
2.298. Thank you.
133.29.
So method number 2 is the cosine of 40. Method number 3, you could use the 50-degree angle and use the sine of 50. But I would stay away from 3 and just work with the angle that you know. One of the things that's going to come up frequently when dealing with trig is exact values versus approximate values. So you'll notice I avoided using the value of x to do further calculations because that x value is an approximate value. I want to use given values or known values to do my calculations. Okay? Beautiful. Okay, you solve for RNS now.
This is really so. Cake and walk.
My walk class doesn't even do about cake. You're walking. Walk. WOC. Written in oral communication.
You don't know, do you, Al?
You don't know the struggle of being
Oh my god, there's no way. Wow, that's a smart class though. Well, I'm saying because he's so good. No. I think I because on the paper test, I cannot do those. I cannot sit down. Dude, I cannot do those, bro. Oh, no way. Dog.
Get it, bro?
Hot diggity.
Sorry, TikTok.
Solve for RNS. I'm gonna solve for S first.
Guys, that's my sound.
So the opposite of
Come on, just swipe off.
Bro, it's not looking good.
I didn't think so, but I needed to ask you a question. It's better to do something wrong now than in 40 years.
I can use this 40 years.
I could put in my papoose constantly. I can come and
Actually, I'm a truck.
I think it's like 40,000 a week.
That's not facts.
That's not 40,000.
With that haircut, I'm not
Who's talking?
Hello, Mr. Reed. I don't know what company it is. He owns a company, and most of the time whenever I go to his house, love it. Yeah,
No
so I
way.
just asked him a question about it.
Actually? No, you have to be joking.
No, he's 8 years old.
Well, your papa is that you said?
My great-grandpa. Papu? Like Papu?
Wait, if you look at straight,
I have a papu and grandma, and then a nona and grandma.
you have a Nona and a grandma?
You have a Noni.
Nona, papu.
You have a Pap.
Noni, Papu. Sean? Do you want to speak?
Dude, I have a... You're bad. Neither do I.
Okay, opposite angle A.
Eddie, we know you're smart. But flexing. And Jack, what'd you get for,
No, I didn't actually, Sean.
I'm gonna ask Siri.
No, I didn't.
Siri, how do you do trigonometry? I could have been
Wait, no.
Wait.
No, it doesn't work.
Wait.
I think I got 10.
Hi, Dude, I thought doing the sine and the cosine were the exact same thing.
Well, it's not an answer.
That's just silly.
Hey guys, it works. But you got something wrong. You're pretty bad.
I used to use both.
How'd you get 35?
Because it's divided by 35.
That's the same.
Because it's hypotenuse. That's the same. Actually, the cosine and the sine are basically the same thing if you use the different. You know, bro, your dad, sorry, like your grandpa does a trigonometry.
He's popping. I do. For God's sake.
Sorry.
Wait, okay, the sin equals the leg opposite angle A. So that was, oh wait, that'd be 35. That's my.
We don't know that angle, do we?
Can you say that again? Mr. Reedy?
Leg opposite, so 35.
Do you always do 3 digits with this?
You can, yeah.
Yeah. Is this right or?
So why?
Oh, sorry. That's supposed to be S. It'd be an R.
Bro, you made me copy off of
I didn't make you.
I got it wrong now because you did that.
It's not. No, it's not what.
Is it S then? Is it S?
No. You don't even know, Sean. I can't tell you. I can't tell you. I can't tell you. You're so funny.
Literally, that doesn't matter.
You can buy it.
So much over there. You explain this to me again.
All right, let's see what happened.
Never mind.
So, what was the positive part of this is that many of you were able to set up an equation. The rather disturbing thing is you couldn't solve a simple linear equation, which was rather disheartening. So, Taylor, let's start with you and tell me how you found R.
I did tangent.
You did what? I'm sorry?
Tangent.
Tangent, good. Tangent of?
15.5
Good.
equals R over 35.
Perfect. Okay. And most of you did this. I assume you multiplied both sides by 35. Okay. So that 35 times the tangent of 15.5 is equal to R, and you found R to be?
9.706.
Is that answer reasonable?
Yeah.
Yeah, it's less than, it's, well, okay, yeah, we'll go with it. Okay. So then you set up an equation to find S, but you didn't know how to solve it, right?
Yeah.
So hold on, before you tell me what you did to find S, let's talk about that equation. So what equation did you set up to solve for S?
I did cosine 15.5 equals 35 over S.
And walking around the room, many people had that same equation.
But you can't multiply the 35 out.
And then everybody had a brain fart because you
Yes.
couldn't solve a simple linear equation. So we'll come back to that in a second. So what did you do to solve for S?
So I saved from what I did before, the whole problem, whatever.
Good.
And then I squared that plus 35 squared equals S squared. And
That
I got-
right there.
Yeah.
Okay.
And I got 36.32.
36 point.
32.
Okay. Well, that seems reasonable because it's bigger than 35. It's got to be the hypotenuse. Okay. Good. The question is, how do you solve that equation? Wow.
Divide everything by 35.
No.
Oh my god.
Multiply by 5.
Subtract. Flip everything.
Multiply over 5.
Oh, that's 0.
Is that
1 over cosine, 1 over
But still.
35.
Multiply 35 by 5. Oh, no.
What if bring over 2.5 and 0?
No. You can't take the 15.5 away from the cosine. All right. This is the only time I'm going to work this through. There's no excuse for you not being able to solve this. But I'll do it once.
Divided by 35. Whoa. Wait, wow.
It's called algebra. So if you plug 35 divided by the cosine of 15.5 into your calculator, you get what? Hopefully you get 36.3209.
I don't want to do this.
I'm not going to explain it.
That's a soul.
You multiply S. Multiply by S. Oh, yeah, the S, and then you divide
Brennan just asked a good question. Can you use any of the other angles? And the answer is yes. Because I know that that angle is 15.5, and that's almost an exact answer. Well, it is an exact answer. I can easily calculate how big that angle is, which would be 74.5. So yeah, you could use that because that's an exact value. Yeah. You can use any one of those angles, the 15.5 or the 74.5. As long as you set up your equation correctly, you'll be good to go. Yep. Oh, we're all done? Okay.
Wait. My geometry teacher gave a lecture on trigonometry, right? Trigonometry today. He really went, oh!
Like that.
A tangent? A tangent? Because we learned about tangents today.